Hello, we have just received a very interesting question from one of our users, someone that's a consultant, very experienced in mine planning, that has accepted the challenge to test SimSched and to give us feedback regarding how the software is working, what we could improve. And I think I have separated one of his issues, which is a really very complex topic and in-depth question about the algorithm and what SimSched does. And what he has asked is this, we can do here, we can see here. And of course, this is just an informal video, and we want to share our knowledge and concerns with you. The point is, he's mentioning here that he would like SimSched to run further in order to improve the results and keep getting better and better and more operational solutions. Okay, just so first of all, I'd like to clarify to everyone that SimSched doesn't have like a timeout, which means it runs until the algorithm decides that it has run enough time and it gives up and then delivers a solution. This may happen in the future, a parameter for the user to choose when to finish the process. So SimSched uses linear programming, integer mixed linear programming, heuristics to deal with nonlinear constraints like the geometries, like the operational constraints. They are all nonlinear. So we need to understand very well about optimization and about mine planning in order to take some decisions during the optimization process. Okay, so what happens is SimSched always looks for feasible solutions first, and afterwards he tries to find better and better NPV. Of course, we have to take decisions. So as we are considering a big set of constraints like slope angles, variable, block by block, we consider mining width, a minimum bottom width, vertical advance rates, production rates over different destinations. SimSched decides which destination to send the block and when to send. So it's a big set of constraints, and it has to take decisions in order to choose what to do, and it always looks first for feasibility and afterwards for optimality. Okay, but feasibility is not always possible. It's something that sometimes won't be perfect, everything will be possible if you ask all these constraints at the same time. And so either we sometimes have to accept it's not feasible to find a solution that's feasible for all parameters, and the other option is to accept some approximations. Okay, for example, nowadays if you run like Lush-Grossman and do a pushback design and so on and so forth, you usually accept some errors. For example, there are some slope angle errors that happens when you deal with block precedences. You accept, for example, that your mine is going to be mined kind of bench by bench within pushbacks, of course, but bench by bench. And maybe you have a period where the production needs to mine like 40% of a given bench, and then the optimizer considers that you're mining 40% of each block of that bench. So this is another approximation. Other approximations are like you run Lush-Grossman. Lush-Grossman doesn't consider a minimum bottom width. So some software simply ignore that, and when you do the pushback design, it designs the intermediate pushbacks, but the final pit, the ultimate pit, is going to have a cone shape. It's not going to respect the minimum bottom width. Another kind of software simply cut the bottom of the pit. So all these solutions are simplifications. They just take a decision that is not optimization, but based on any optimization criteria. Okay, so what SimSched tries to do, indeed it's a huge challenge. Okay, I bring here to our website just to show the steps here. What SimSched aims to do is not that inside we do pit optimization, pushback, shadowing, and so on and so forth. No, we have an optimization algorithm that goes straight from the block model to the final result. So of course, this will be much more complex to solve all the details at the same time, given that we're not giving transferring the responsibility for the user, for example, to choose which one of the nested pits am I going to consider in order to do the pushback design. This is not an optimal decision because you're not considering the value of money in time. You're not considering operational constraints, mining width. You choose some that look reasonable, and then considering that you run an algorithm or you choose manually ways to manipulate those surfaces, those solutions in order to respect a mining width. So notice that you, as a user, you have to take a lot of decisions during the process. And of course, if you're an experienced user, you're going to take good decisions, you're going to get there. I'm just bringing the point that SimSched tries to do everything at once. So the challenge is huge. We're going to face, we have been facing, but we have surpassed many challenges, and we truly believe that we are going forward in the right direction. Okay, so what we need is from just replying to the questions made here. It's not a matter, if SimSched doesn't produce a solution that, if SimSched produces a solution that violates part of the constraints, this is because SimSched hasn't found one solution that's perfect and achieve all the constraints, or SimSched doesn't have implemented yet that kind of, for example, geometry. For the question of this user is a matter of geometry. Something doesn't look like a mine when SimSched delivers a solution. So in those cases, the best thing you could do to help us to improve is to show us, like give us, if possible, the data set with the parameters that you have executed. If not, if you could record a video and show us into details, because we can bring this from the support team to the development team, and we can include in the pipeline some ideas and try to get better results that respect that kind of geometry that our mining users, we know that many things are not ready. The same way that when we run nested pits, we don't have a solution in one step, right? We need to pass through many steps. So SimSched is not perfect. Our users are going to have at the beginning to do some manipulations using surfaces to achieve some results that they think that are reasonable. But we truly believe, and if you're testing SimSched, I believe if you take and run and have a solution, I believe this solution is very interesting if you're trying to test many possible scenarios and things like that. It's getting each time closer to the reality, okay? And we count on you to provide us with situations that you think are not operational, they don't look like a mine. So please let us know. This will help us to improve for future versions. Okay, thank you.